And if you have the YouTube channel open, mute yourself, because otherwise you will have a nice little echo with a delay of 10 to 20 seconds, which perfectly brings you out of everything you thought you're in it.
I just had the chat open here just in case I catch some questions.
I will collect the chat as well. I think you're streaming, so let's say hi. And we are on time. Hi. Welcome all. With me today is Renato, and he is in a really great mood, and he has an even better presentation for us. So as always, if you have any questions, feel free to post them in the chat, and I will collect them and ask Renato at the worst times I can imagine, which is usually around the end. And I will stop talking now and just hand over to you.
All right, thank you very much, Roger. Yeah, welcome to the presentation. I'm Renato Costa, and today we're going to talk about Bootiful RSocket with coroutines. And if that sounds like a lot of things, it's because it is. So I just wanted to get quickly started and go through a little bit of an intro of what we can expect for today. Then we're going to talk a little bit about Spring. We're going to talk a little bit about Kotlin coroutines. We're going to talk a little bit about why going reactive and why we're having this whole conversation in the first place. We're going to talk RSocket, and we're going to have a demo. So it's a little bit front-loaded, so bear with me, and we'll try to spend as much time coding as possible during this next half an hour, 1 hour that we have ahead of us. First things first, I really wanted to get into this intro mood here and talk about what is this, right? I am not the guy that developed the RSockets. I am not the guy that developed coroutines. I'm just a developer, like 99% of us. I am pragmatic. I want to get the domain stuff done. And this has been the journey, basically, I've undergone through this year in order to better understand the tools that we have available. Because sometimes we are using a drill as a hammer accidentally when we have much better uses for them. And we will introduce all of these concepts we want to explore first, so we all are in the same, more or less, middle point. So I'm not going to give you the masterclass in Spring or RSocket today, but I will point you out to where you can go and find those masterclasses, right? And then once we talked about all of those things, we want to make some deliberate choices. And I think that's very important when I'm working on a new project, when I'm getting something done that I'm looking at my options, and I know that there might be something better, but I'm happy that the technological choices which I've made are fitting the product I'm willing to build. The product matter, the technology is secondary to that. So once again, we have a lot of tools to fix our problems, to get the solutions we want done, but we have to understand what our actual needs are first and then make that choice very explicitly. And honestly, today is all about being productive. It's about trying something out. So I want to do a small demo. We're just going to improvise together. It's going to be a mess. It's going to be awesome. So bear with me and let's get on. First, I want to talk to you about Spring. So in my opinion, using Spring nowadays, if you're like in Java or coming from Kotlin, if you have a decently sized project, it gets you working and it gets you working fast. But there's a lot of confusion sometimes. So I just wanted to level up the playing field here and say, you have the Spring framework, which most people have heard about, which will be an application framework that will give you tools for inversion of control, for DI, and for a bunch of other things. But normally, we use interchangeably both Spring and Spring Boot, which is a way, basically, to create Spring applications on top of that use Spring on top of, and it's easy to get it done and to start being productive fast because it uses sensible defaults. So think of it as an opinionated version of Spring that just gives you the tools that you need to go flying. And if you don't want to choose the magic, as it said, that comes out of the box, you are more than free to actually add your implementation. It's entirely built to be customizable, and yet it tries to be opinionated enough to cover most of your bases. So normally, whenever you're using something Spring related or in the ecosystem in itself, it's very sensible to start with a Spring Boot project. It's good to just like get the ball rolling and to get you into a nice place where everything is making sense. However, I just want to make 100% clear before I get this question later. Can we do any of those things you're talking about with Kotlin coroutines without Spring? Yes, absolutely, and 100%. You have, for instance, Ktor that's built on top of basically coroutines. It's already out of the box and it's amazing. You have OK HTTP, you have HTTP for K. You have a lot of crazy, nice things that just take advantage of coroutines. It's not something stuck in the Spring. The same goes for RSocket. Why would we choose to do so? Because it allows us to just like hit the ground running and to continue going forward as fast as possible. Cool. And then I've been using this word coroutines, and that's something that if you have worked with someone doing Kotlin recently, you can't stop them from saying coroutines all the time. And if you Google it, what it means, you just go say, coroutines are computer program components that generalize subroutines for non-preemptive multitasking by allowing execution to be suspended and resumed. And you go, huh? So I want to break that down, but before we break that down, I like asking myself, why? Why are we talking about things? So why are coroutines basically? Nowadays, it's very important to care about blocking of individual threads. So think with me, if we have an application, the application has so many threads, there's only so many resources you can do. You have to think before you actually stop something to wait for a response while you're doing that thread. And this has been like a classic problem in our field for a long time. You have like, for instance, UI threads when you're doing an Android. You can't like update the UI if you're not doing the proper thread. You have process-intensive operations that can just like overwhelm thread pools, making the entire thing go unresponsive in your software. And honestly, this is a big thing, but nowadays, since we're doing like mostly microservices and communicating and having latency issues and server issues and communication issues, waiting effectively to me seems even more important than building the best algorithm possible. We think we jumped from the age of just like trying to figure out the big O notation to have a linear performance and spend most of our days trying to optimize how we wait for something to come back effectively. And coroutines are amazing for that. What they're essentially devices that allow us to execute code without blocking. And the basic idea is you can suspend that code and you can resume that code. And in essence, they are basically just state machine objects. They have a context, a state, and they can stop, yield their resources to other coroutines to execute, and then they can resume from that point on later. Cool. And what about Kotlin coroutines at this point in time? So Kotlin Coroutines is a library that you can import to your projects. It doesn't come pre-baked into the language, for instance, as if as async and await comes in C#, for instance, or in the ECMA script definitions nowadays. But it's a library that provides you tools to build code that's non-blocking with coroutine primitives. And it's amazing because of three things, in my opinion. Okay, it's a very inexpensive mental model for threads. As I mentioned before, it's not that the coroutine is a thread, but you can think about it as a thread in terms of application resources and mental model. Think about this. This is a heuristic. Threads are expensive. Coroutines are very lightweight. It helps you simplify code, so you don't need to trust on callbacks or memorize a million operators when you're doing with Project Reactor or RxJava or something related to that, although this is more or less changing, but I'll get to this later. Then it helps it make easier to write idiomatic Kotlin code, just things that you can just look up and see that it's Kotlin code and understand what is happening, and that it also behaves asynchronously. Emphasis on easier. It is not something easy to do. You still have to worry about all of the classic issues about asynchronous programming, about shared mutable state and stuff like that. But it makes it very, very easier to focus on what is really important, your code, your business, right? And I wanted to give a quick coroutine sample to prove my point and to also put some code in front of us before we start going forward with that. So here's what I'm gonna do. I have a very little piece of code, and the basic essence of it is the following. I'm gonna create a list with 100 items. Each list of this item is gonna be a thread. So I'm initializing 100 threads, and these threads will just sleep for 1 second and then say like, hey, I executed. When all of those threads are done, then my service is over. And here to the right side, I wrote a second example that's basically the same code, but using coroutines. What are the differences? I have a run blocking block here. What does that mean? I'm really just bridging the world of non-blocking with blocking. And this is the most simple primitive. This is what you would use for this sort of toy examples where you just have a fun main and you start running. Normally, when you were using a framework or something more involved, you will have different tools to bridge this gap. And we'll get to that when we are talking about Spring soon. But just consider that everything that runs here inside of this block is non-blocking. And the idea of the code is the exact same. I'm just going to start a list with 100 items and launch 100 coroutines, and then each of them will just wait, non-blocking for 1 second, and then say that they executed their job. Why don't I have to join here? Because coroutines depend on the scope. There's this thing about structure concurrency. I really recommend you guys read into it. But basically, this also spawns a coroutine, and this is only done when all of the children are done executing. So therefore, I don't even have to worry about forgetting to close the coroutine later and having like a dangling process on the kernel. I can just program it in a way that it makes me avoid making mistakes accidentally. So I'm going to run those two code examples, and I want to see in chat if you think, okay, what's going to happen? Is there going to be any problem here? What is going to be the time execution? So if you have anything to say about that, that's now the time. So I just ran here the code with the threads, and all it does is really just print the thread in which it was executed, and then just say like, hey, I ran for so long. This is my thread. You see that they are out of order, and I took basically 1 second. So it works as we expected. We ran 100 threads in parallel. They executed all in 1 second. They're done. And now we're going to try the same thing for the coroutines code. So really important things here. It ran roughly in the same time, give or take some overhead, but all of this execution ran in a single thread, and all of it ran synchronously. Why? Once again, remember, think of it as a state machine object in which the first job to launch says, oh, I need to wait for a little bit. I yield the resources. The second job comes, the third job comes, and so on and so forth. So because this is a deterministic piece of code that will always have the same sort of delay, you can run this 100 times and then get the same result, same order result. But now you ask me, hey, it doesn't matter. Like it ran the same piece of code exactly. What's the difference? What's the gain? What if I didn't have 100 jobs to run? What if I had 100,000 jobs to run? What would happen? Well, it ran in close to 2 seconds. There was some overhead. And once again, everything ran with one single thread, and all of the jobs ran once again in sequence. It's deterministic, right? Cool. Does anybody know what will happen once we do this with the thread-based code? So a few seconds to see if anybody wants to hazard a guess, and how long is this going to take? I'm seeing some typing here and there. So I'm just going to run it and see if the replies will come in true. But if we do the same thing, we run out of memory. My laptop cannot hold on to this amount of threads. They are very expensive. So right now, if I'm just doing a typical thread-based sort of application, I have to start thinking about strategies to handle this. How I'm gonna partition the code, how I'm gonna change it around. I think I see Lucas there, gonna break. Exactly right. So everybody got it right, I guess. So here is the crux out of it. It really tries to make you focus on what is important to you, what sort of job that you're going to run, and all of the rest of the strategy can be dealt just by itself. By the way, and this is using only one single thread. We are not limited to running coroutines in a single thread. We can run a coroutine in a thread pool and have this entire thing much more efficient as we're going forward, right? And that brings us to this question, like, hey, why reactive? I think it makes it very clear how much more you can do with less, once you're doing reactive coding, right? But it's not the only horse in the game. So here I have like a very simple drawing of a servlet-based approach. So this is what we are typically used to seeing. Say we have a Tomcat instance running there, and we have a bunch of requests coming from the internet. What will happen is the servlet container will just create a new thread. We'll just go to your endpoint, your servlet, or whatever, and then once the job is done, then we'll give you the response. And that will run only on that thread. So more calls, more threads. And there is obviously, as you saw, there's a limit to that. But normally it's more than enough. You have here, for instance, an example in a Spring-based example using Spring Web. It's the traditional way of doing coroutines. You define a REST controller. Your REST controller defines a get mapping, for instance. And this get mapping, whenever you get a request for that, you typically just get one thread. This transaction is handled in one of the threads, and then it's returned. Yes, I know that this is like a useless assignment here, but I just wanted to highlight the type, guys. Just bear with me. Cool. You also have, for instance, the same thing for lists, right? So I just returned the primitive list of my transaction, of my POJO, so to speak. I make my query or whatever, and it just returns once it's done. That's cool. This, you can see, for instance, typically the default is to have 200 threads, and that handles entire applications. And for many, many, many cases, it's more than enough. Because really, unless you're planning to handle like a lot of different outcomes, such as, do you need to do a lot of asynchronous things? Do you need to use reactive programming? Are you talking to streams? Are you handling events in a huge volume? Are you planning for spikes? Do you have to scale very sensibly or handle bursts of things incoming all of a sudden? If you require back pressure support, if you don't need that, if your application is very simple, you can keep it simple. And Spring already gives you the tools to do that with Spring Web, as you saw just now with the code examples I just gave, right? And you have a whole myriad of tools to handle that. Cool. Mentioning again just really quickly about back pressure. So it's the resistance or force opposing the desired flow of data through software. So if you think about piping in a house and the back pressure, that's more or less from where we got the term. Classic example is reading from a hard drive, right? So if you have a read speed of 150 megabytes per second, and you can just write for 100 megabytes per second, if you just try to do everything as fast as possible, you're gonna always have like 50 megabytes in the buffer, so to speak. So you have different strategies of how to handle this disparity in velocity, so to speak. One of them, for instance, is to just say, well, let's just read as fast as we can write, so we don't have to manage a buffer and stuff like that. Why do I talk about this? If you have the reactive approach, this is an even simpler and dumber approximation of the whole model, but you have your Netty application just running there, and you're getting requests from the internet or something like that to your application. You're getting some REST requests. What happens is it tries to just like, hey, I took your request. Here's a response with an object identifying something that will be in the future. So there you have your completable futures, your promises, so on and so forth, right? And if you are using this with Spring, what's the programming model you use? Well, once again, you just create your REST controller, you have your get mapping, and then you return a mono of that transaction, or you return a flux of the transaction, basically like the list of that transaction. If you see that Spring, this is in WebMVC, it tries to make it opaque to the user that you were dealing either with just the blocking type notation or the non-blocking type notation, because it is the same programming mental model. You don't have to worry about the choice that you've made before. You can just focus on your code, and that's pretty interesting. And then with Kotlin and with coroutines, you can actually go ahead and just go and do something like this. You add the suspend modifier to your functions, and it's already accepted from the get-go from Spring Web Flux, for instance. And you can just return either your transaction right now. I believe you can do that also with monos, but just bear with me. And if you have a collection of things, you can just return a flow. That's basically the equivalent type of a collection, a publisher. So if you have the reactive publisher interface, the flow implements that. One extra real cool thing. If you see here that I'm returning a flux from my service, imagine that I am refactoring my own application, and my application was dealing with a third-party tool, and the third-party tool uses Project Reactor, and it returns me a flux of information. There comes already pre-built with the Kotlin X library for coroutines, the AsFlow converter, the extension function. So every time you have a third-party tool that just uses fluxes or monos or something like that, you can just have already pre-built tools by the Kotlin team itself that you can just convert to coroutines and continue working with them. Cool. So once again, we ask those questions. Do we need to do asynchronous programming and reactive? Yeah. Do we need to scale a lot or handle bursts of information and have some back pressure support? The answer is yes. You have tools also with Spring for that. So you have Webflux, Spring Data Reactive R2DBC, you have Reactor or coroutines, and you have also RSocket. So I'm getting to the meat and potatoes of what is RSocket and why do I want to talk about this. RSocket is a protocol that really enables us to have like high performance, fault tolerant messaging over a multiplex duplex connection. And that sounds like a lot of gibberish, but we're going to break it down. It is transport, message format, and language agnostic, and it's built on top of the reactive streams specification. What does that even mean? Multiplexed. You don't need to create connections all the time to get responses. So once there was a connection between client and server, which is not even client and server, you can think about it as responder and requester, requester and responder, I apologize. With one connection, multiple messages can be sent, eliminating the need to really make a lot of handshakes, a lot of expensive transactions. You can just focus on the communication in and of itself. It's duplex, like I said. There's a requester and receiver. They are mirrored. So at some point in time, the server can ask for things from the client, so to speak, and the client can ask things from the server. Both of them can have, for instance, back pressure support and back pressure and the ability to control how much data is coming in at any given point in time based on how much they can process at the moment. And that's pretty interesting. And it's pretty agnostic. What does that mean? You can say, hey, I want to do my transport via TCP directly. I don't need the overhead that HTTP does. I can use WebSocket. I can use Aaron. I know a lot of people in the finance sector are using that right now. Client implementations, you have Kotlin, obviously, you have C++, Java, JavaScript, .NET, Python. You can just use it. And the payload can be binary. It can be protobuf. It can be JSON. It can be a bunch of things. You decide how this encoding can be done. And why is it so interesting? And why do I want to talk about this? So it has 4 interaction models. What's the first? The first is request response, right? The first is request response. So imagine you have like a just normal HTTP connection, right? And you have a single request and a single response. It maps very easily to this mental model that we already have with REST, but it's not the only thing it actually allows us to do. For instance, it has a fire and forget method that can allow us to just send a request that may contain a payload and not wait for a response. If the server is alive, if the server has an error, it doesn't matter. It just lets us send an information forward and then continue on with our lives. Why would that be useful, you'd say? Well, think about it. Imagine if you have some sort of application that sends geographical data around to the to your server, right? If you miss a few of those data points, it's not a problem because it can still track with the other data points when the request came by, and you don't need to wait for it. You can just send the requests as soon as possible. What is request stream? Well, what does that mean? You can send a request and establish a connection with one payload, and then the server can continue sending you messages back as long as you want to take them, or as long as the server has something to communicate. So it's a one-to-many situation. And the really, really, really interesting, but really hard to think about some use cases to do is the request channel, in which that happens bidirectionally. The client keeps sending information to the server keeps sending message back to the client. You see, it's kind of hard to think about this as a requester and responder right now, because they are both requester and responder at the same time once that handshake was established. And that allows us a lot of freedom. Think about it. Imagine you had your mobile game or a browser game or something like that, that would say, hey, every new player that comes in connects to my server using a request and response. Every time they do a movement or they change something in the game state, this information can be automatically broadcast to whoever else is there connected in the server. And then whenever someone else does in the server can inform the client as well. That sort of interaction can be very transparent, and there are a lot of possibilities that can happen with these interaction models. You can then take all of this and say, I want to create my own server. I want to serve RSocket. Cool. So this is a snippet of code, like Kotlinized, so to speak, that is in the rsocket.io website. But the idea is I create an acceptor, basically handler, to accept the request that you're saying. Then you have to define how you're going to decode the payload that is coming in. Then you have to say what is the transport that you want to serve this, and then just serve your application. Cool. We don't need to do that though, because once again, you can just focus on your approach using Spring Boot. And this is entirely new and you don't know how you're going to handle it. How does the Spring team enable us to do that? By using a very similar approach to what we use for REST right now. So we just define a normal controller. We don't define a get mapping, we just define a message mapping to that. And then all of those interaction models can map to this interaction, to this annotation, depending on what you return. Hey, are you taking just one value and returning one value? Well, this is a request and response. Are you taking a value and not returning anything? Well, that's a fire and a forget. It's very interesting the way that the team made this very opaque, and that just allows you to take advantage from this from the get-go and to use whatever reactive thing is. So once again, this is just a mono example. So how you would do theoretically in Java using Project Reactor. There's nothing wrong with using that in Kotlin as well, but you don't necessarily need to. You can just return, but make the functions suspend, and then you have coroutine scope in there, like if you need to. And based on that, I kind of can move now into a demo time. So Roger, do you think it's okay that we answer some questions right now, or should we do it after the demo?
We do have one question already, so I will just throw it in. I think it fits rather well in here. So Eriko asks, what's the performance difference between RSocket and plain old REST?
That is a fantastic question. So when you think about this, is no matter what, RSocket is theoretically more performant than HTTP. So a REST call needs to go over HTTP, and HTTP is over TCP, of course, but it has this extra protocol layer, right? Whereas you can just with RSocket just say, hey, I'm just going to call you directly on my TCP port. What would that imply? Yeah, you can do that directly from the browser. So if you have your browser and you're trying to call like an RSocket service, you can just like, hey, I'm just going to implement something and call it directly. You have to use a transport layer such as WebSocket, right? You can just like TCP from the browser to a server. But suppose you're doing server-to-server communication, and you just want to send binary data because two services need to communicate. You can just go as low to the metal as possible and try to squeeze as much as you can out of that protocol without needing to go over and say like, hey, we're going to package this through REST. One very important thing I can't mention right now, because once again, this is a very high level thing. RSocket allows a lot of things. So it chunks the messages that it needs to send you, and it will, once established the communication, it will chunk the message that you need to send, and then we'll send the chunks with a specific ID so that the receiver can receive it. Suppose there is even a connection error. You went out under a bridge, your phone lost 5G or something like that. It actually can reconnect later and figure out from that saying, hey, we knew where we were before. We have some sort of fault tolerance to handle that. So the protocol in and of itself is built thinking that not only are we going to let you be performant, not only are we going to give control and back pressure support on both ends of this communication, not only are we going to make this as performant and as close to the metal as possible, we're also going to try to make it very fault tolerant and very flexible. So it's pretty interesting to see. In many, many, many cases, especially service-to-service communications, this would be a way better fit than just using the plain old REST and code and just badgering yourself with all of the error codes and the error handling and the network support and all of these things. I hope that does answer the question.
Let's give Enrico some time to respond. And also, he actually added. Also, does it have something like a circuit breaker, or does it need to implement it as well?
So RSocket in and of itself doesn't have a circuit breaker because it's just a protocol. RSocket in and of itself doesn't even give you a way to encode and decode the payloads that you're sending because it's just a protocol. It gives the choice to you. When we are using it in Spring, we are getting, once again, with Spring Boot, we're getting some very nice sensible defaults. For instance, it gets CBOR as the payload as default, and it gets you a lot of things. So the funny thing that you can start taking advantage, and why I choose to use this framework on a daily basis, is if I want to use Spring Security with it, it has integration. If I want to just like say, hey, inside of it, I can just use Resilience 4J in my application and implement it as you know how to implement already in your applications. You can do it. There's nothing stopping you. It allows us to be very lean about how the communication is going, but it also integrates very nicely with the rest of the Spring environment.
There is it's he wrote it as a statement, but I will just throw it in and maybe you can say something about it. Is from David. He said that I hear mobile games are very spammy with requests. Do you know anything about that?
Well, I am not a game developer, so that was just a real good example. But think about it. What if we didn't need to get all of these state messages from our mobile game, right? With the sort of approach we can do with coroutines, with either with Reactor or with flows, for instance, we can, for instance, say, hey, you know what? I don't want every single call that comes in. I want to conflate them, and every 2 seconds, I want the last one to come, so I can only update. And that's very easy to compose. I'm just going to start my IntelliJ here real quick, so that we can go on, and maybe we can try to do something related to that.
Yep, cool.
Cool. I see also a question from Nicholas. When I hear channel, I hear stateful connection. So how do you handle that? I think I'll try to implement here at least the channel interaction. I figure we will have enough time in the next 15 minutes or so. If I don't get it to there, I promise to come back and try to answer this one. Okay, cool. So one thing, I don't know why every time I see a talk, people just go to start.spring.io, and it's an amazing website, but you don't have to. So if I can be lazy, I can just start a new project here in my own IDE, and that should be fine. I'm just going to call this the VKUG demo. It's a greater project. It's in Kotlin. I'm just going to use Java version 11. That's fine for me right now. And once again, all of the nice things about the Spring, about choosing what tools you're going to need, you can choose here. So I'm going to try to keep it very simple. I'm just going to take the DevTools and the configuration processor because I love them. And what I'm going to do is I'm going to go to messaging, and I'm going to go to RSocket, and I'm going to say, hey, we're going to serve RSocket applications, Spring messaging, and Netty. So we're going to get ready for that. I'm just going to hit OK. And it's a little bit bigger than I normally see my screen. So if I'm fumbling around, just bear with me, all right? So here's the very interesting thing. Whenever we start a new Spring application, I believe most of us have done so, but if we haven't, the two main important parts of it are these two files. You have an application.properties file that will govern how your application is configured and stuff like that. And you have your application where you'd start. Here is where you configure the Spring Boot application, and here's just the static main that will start that application. That is pretty self-contained. So if I just start my application that I just created with RSocket, it will start, and then what will happen? It finished. So that's a really interesting thing. Most of the times in Spring, you opt out of something. When you add a dependency to your project, you opt out of using it. So if you don't want to run Flyway manually and you have the Flyway library in your code, you just go there and deactivate Flyway. For some reason, for RSocket, it's the exact opposite. If you haven't opted in to RSocket, you can't use it. So you go to your application properties, you go there and say like, hey, I want to serve my RSocket here in this particular port. I'm choosing 99999 because I like the number. And I'm just going to run my application once again. And now you see that application starts and stays alive. So that's like step number 1, so to speak. What I'm going to do also, I'm going to go to my build.gradle file, and I'm going to add manually the latest Kotlin coroutine core and reactor implementation, because if time allows it, I want to implement a shared flow example and show it off a little bit. So once we are here, I'm just going to make some spaghetti. So normally you would just get this into different files, but what I'm going to do, I'm going to create a new controller. So I'm just annotate this controller and create a new class saying it's my RSocket controller. And then we can start building our interaction model. So another thing we can also do is just like create a little service to say like, hey, my controller is super dumb, but my service will be smart. So I can say like, it's my transaction service. Why transaction? So I'm just thinking about like a generic sort of DTO. So suppose you were having some purchases and sales in your service, and then you have a database for that. If we have time, we're going to put a database in our system and try to access like a Postgres database. But suppose you have to map a transaction, a financial transaction, and then just work with that DTO POJO. We say POCO? I don't know, right? So just for that, I'm also going to create a data class for transaction, and I'm going to use a little bit of a cheat sheet here, so I don't have to type all of this POJO, because that's not really important. So let's suppose I have a request, right? Like I want to query one specific transaction, and later, only if we have time, we put a repository here in the middle. Let's see. So we have the message mapping as we saw it before, and we can start, for instance, with the request response. I'm just going to call it RR so it's easier to type, and we're going to go like suspend fun, and we're going to request response, and then I'm going to take maybe an ID, which is an UUID, which is not like a simple type, it's a Java type, so something extra for us to play around, and it will go say, for instance, let's suppose we want to get a transaction by ID, right? So my service here will implement one, so get by ID, and it will take an ID UID, and it will return a transaction random. Oops. I'm going to also implement a random transaction kind of thingy here. Bear with me. This is just a simple example. I'm just instantiating a transaction with random UUID. Let's believe that we said, hey, it uses this UUID here. So I'm going to pass the ID for this guy. It's a UUID nullable. So it's either the ID or Elvis is just a random UUID if I don't provide it. Cool, cool. Yeah. So we want to receive a UID and then return a transaction. So we're going to be very explicit about it. We're going to say like we're returning a transaction DTO, and we need to access our transaction service. So I believe that most people have used Spring before and know about the magic. But these annotations I'm having here on top of my classes basically allude to me registering them with in the Spring application context. And if I need to use them, I can just tell Spring itself to say like, hey, give me an instance of this guy or the instance of this particular bean, so I could use it, right? So I don't even have to write out-of-wire nowadays anymore. It's pretty fun. And I will just return this particular guy. So this is a very simple mapping. It's a pretty banal example. I hope I didn't make any mistakes and it will run and I don't look too foolish. And we will build it. Yeah, anyone remembers the XKCD Gladiator thing? Hey, it's compiling. Still relevant, still relevant. Okay, so I restarted my application in debug mode. So if we want to stop it around. So one way you could just try testing it out is by using a thing called RSC. So if you want to understand what they are aiming to do, they are trying to be the curl for RSocket. So you have this command line, you say what is the connection. So you say I just been passing the TCP directly to it. And I'm saying like, hey, the route is, what was the route I defined again? RR. And then this is a request response, I think. I forget how the thing goes. So RC must help. So I am very bad at remembering syntax. So I want to request a response and I need to send some data, and the data is that UUID. So what I'm gonna do, I'm just gonna generate a random UUID here real quick, copy paste it, go back, and I got an error. And that is amazing to do live in the application. Huh. This is what I was afraid. So there's another way we can do this real quick. It's basically me being bad with command lines. But what I'm going to do, I'm just going to create a JUnit test real quick. And the interesting thing about Spring Boot, not many people think about that, but it just allows you to write tests very easily and integrate those tests very easily. So let me just see if I stopped my application real quick, because I'm going to need that port. And what I'm going to do, I'm just going to set some auto wiring here. And what does that mean? So Spring not only gives you already pre-baked ways of serving your application, but also of building a request for it. So you can just auto wire this builder here, and it will just work out. And this guy, the Spring RSocket server port, is what I configured here in my application properties. Well, cool. Besides that, I could just test the request and response. And I'm just gonna, once again, cheat a little bit if my application allows it. Come on. Okay. So what I'm gonna do, I'm just gonna wrap this into a run blocking because I don't necessarily use a JUnit every day. I prefer to use a code test right now. So I'm not exactly sure what's the best way of getting something run blocking suspension code is with JUnit. But what I'm gonna do is the following. Imagine I have a requester here and I'm gonna say, hey, my route is RR. And what I can do is saying, hey, my data is UUID.random UUID. And I'm gonna say retrieve and await. So, and what it's gonna retrieve is gonna retrieve a transaction, right? So this requester here will return me the result of my RSocket request. Once again, I build a request, I say go to a specific port. This apparently is now deprecated since the last milestone version. This is nice to know. And right now, I'm just gonna get the result of that transaction, and I can just do some assertions on top of it. So I'm gonna go assertions.equals. Let's say if my UUIDs are equal. So hopefully I'm not making a fool out of myself and this is going to work. But that is the way that you can build a client also code-wise. And I am forgetting something here. I have one too many. Somehow my laptop is quite slow, but yeah. Meanwhile, if you want to pepper me with some questions while we wait for the compilation, that would be also cool. Yeah. And there we go. This is just how you call it. So I am probably not that good at RSC full and sending values, but you see that I don't need to configure anything in my application properties if I don't need to. I can just use the sensible defaults, or I can just go here to CNR socket and see what I want to use. If I want to use a SSL, if I want to use some protocols, if I want to change and register some beans later to say, hey, this is how you're going to do your transformation, I can also do that very easily. And you test as if you wrote, for instance, for, where the mental model, if you already used to Spring, is very easy. So you can very easily start taking advantage of it. Meanwhile, I want to write now the other use cases. So if I have, for instance, fire and forget, that's very simple as well. I can just say suspend fun fire and forget, and then say, hey, I return a unit. You don't necessarily need to do that. I just like writing it like this, so I remember. And let's suppose I'm just going to print something on the UI. I theoretically would log this, but I don't, want to write a lot. So hey, I'm working. And to also do something pretty interesting, I'm just going to do a thread sleep right now, right? Here, look at this very interesting that happens. It says like, hey, this is an inappropriate blocking call. Why would that say that? Because the suspend modifier that we add here is basically a contract. When you're saying that something is suspenseful, you can see here in IntelliJ on the gutter side, or if you enable it here before the particular transaction call, is a contract that you're saying whatever is going to run in this block inside of this code is not going to block my thread. It's going to allow me to continue utilizing whatever else and have the resources open. So whenever you have this sort of situation, not always the compiler is going to catch this ahead of time, but it's important that you catch those sorts of occurrences because they can tank your application. For example, in Kotlin, you can actually define where and how you want your coroutines to run, right? And one thing I can do right now is exemplify that. So I can say like this guy here is inside of a coroutines call. So I can just take advantage of the coroutines call that comes inside of this the parent of the suspend call coming from Spring from the netty pool, and I want to say, you know what? I want this guy here to run in a different context because this guy is blocking, and I want to say what this context is. Kotlin already provides you a few dispatchers. So what is a dispatcher? What is this thing that I'm writing here? So I'm telling it saying, hey, whatever is going to run here in a non-blocking manner in this particular coroutine here inside of this block is going to run at this dispatcher. Think of it as a control mechanism that can tell where and which thread in which resources your coroutine, your block of code can run inside. The Kotlin team is very aware of that, so they gave us basically two very important ones when we were thinking server side. I am not that qualified to talk about mobile, but you have the default dispatchers, which are bound by your CPU. They are bound for CPU tasks, so there are at least 2 threads in this thread as executors thread pool, and at maximum the number of cores in your machine. So if you're doing something that's CPU intensive, it may be worth to run it on the default thread pool. And you have the IO thread pool that has at the beginning 64 threads, and they are made for things that you have to wait and that are blocking, for instance. So one thing that my projects currently have is clients that have to block because we are using a pretty decently outdated technology, and we don't have that much escape in short-term situation. So one thing we can do is just wrap this blocking code with context and give it to a thread pool that is just based on waiting and allow us to free up the resources of the CPU-bound thread pools to continue running without any big problems. I want to rerun my application right now and say, let's try testing the fire and forget to see if my RC full is much better now. So I'm gonna RC is this TCP localhost 999. Minus FNF minus R FNF, and well, nothing happened. Well, that's the beauty of FNF. Well, there wasn't an exception as well. So even if there was an exception handling happening or something that just didn't execute at the end of the day, I don't really get why there was an exception right now, but it doesn't affect the caller. like I said, if you have something that you need to keep calling and you don't bother to see if there is going to be a request to happen. So I see a comment from Nicholas that he lost the thread of the demo. I understand that completely because there are a lot of things coming together, I think, for this particular thing. I tried to bridge a lot of topics, and that may have been a big mistake. What I'll try to say is, you can very easily take advantage of using RSocket right now and do some amazing things with it. I'm just going to try to implement the rest of the interaction models so you can see it's like not crazy and it's not insane. It's something that you can do on your daily basis. And all of that pre-baked information I said before is just so we understand all of the work that is being offloaded to the Spring side right now. I'm going to do the string mapping right now, real quick. That takes a flow of and here's the thing you can do, right? So imagine I want to build a flow. And what is a flow? Flow is the coroutine primitive, so to speak, that will allow you to send a stream of data, a flux of data, right? So the equivalent to that. And how does that happen? It happens that you can just define with this builder a specific block of code here and emit a value at the end of it. And whenever it starts being collected, it just runs idiomatic Kotlin. So suppose I wanted to run like this, right? And say, hey, transaction service.get by ID, uid.random uid, right? And I just want this to happen, that I'm going to just emit 20 random transactions at once, or I'm getting the 20 latest or something like that. I can just write Kotlin code that will behave as a flux. I don't need to memorize exactly what is the particular scenario that I want to do for my piece of code, right? And once again, I don't quite exactly understand why RSC is not working and the port is in the right place. I'm going to try rerunning the application and using RSC for one last time. Otherwise, we're just going to write another test for that guy. Yeah, finally it works. So it can give me that, right? But what's the point? It's just like listing something. But what if it wasn't just a limited amount of data, right? What if it was something that was kept alive, and instead of repeating 20 times, it also kept repeating 1,000,000 times, right? I want to implement the last one, and then we'll tackle this again. I'm just going to copy paste real quick and just write channel. And the difference between this is like entry channel. And this time I'm going to do something a little bit more funky. I'm just going to accept flows of string and emit flows of string, right? And what will happen is the entry channel dot collect. I'm going to print whatever comes from that entry channel. And I don't have the correct import, I believe. And now I do. And then I'm going to return a new flow that, while true, I'm just going to emit like random string. I could get like one of these things that are collected here and make sure like they're talking to each other. I don't necessarily need to. I can just be saying like, hey, whenever this guy sends me a message, imagine a chat, I just send it to an event stream or a database, and I can, whenever I get something from my database, I can stream for the guy. You can choose how you manage that collection, right? And I'm going to rerun the application, and we're going to write a test for this guy. I didn't need to run the application. So we're going to go here to the socket compiler, and I'm going to do the following. Are we good on time, Roger?
All good, all good.
All right, cool. So what I'm going to do is write a very silly test for that, in which I'm going to just create a flow. And obviously, there's much more to this flow. It's a really interesting format that you can balance out and do a coroutine backed publishing, and you should just definitely check it out. I'm gonna send some resources about that. But this flow is gonna just say, hey, while true, I'm gonna emit my funny string. So while this code is running, this is just gonna go there. And I'm just gonna say my route is the channel route, my data is my entry flow, and I don't want to retrieve in a way. I want to retrieve a flow. So I don't even need to use the flux data type. And why is that useful? Because I can just use the reified, well, Kotlin types. I don't need to pass the Java type and stuff like that. And then I'll have this flow, and on top of this flow, I'm not gonna write any assertion, so this is not exactly a test, but like on top of this flow, I can just collect the values and start, printing them, right? Print ln, and then I get my value, and I start printing my transaction that I'm getting. It's not a flow transaction. I apologize. This is a flow string. So the type here changes. Cool. I can run it. And this is just going to be the shoutiest test you've ever seen in your life, and when the strings are going to be shouting at one another. And it will say, what's the point? What's the point of all of it? All of this? Point is, now this guy here as the requester has control about how the response is coming. So when I'm retrieving that flow, what I can do, for instance, to say is, I want this to have a buffer of like 20 messages, so I can process 20 messages at the same time. And then I can also say, like, you know what? I don't need to do like a filter and a map, and they have and those the flows have those particular operators, but you don't necessarily need to. They try to have very simple operators, and one of the most powerful is the transform, which transforms a flow into a flow. But then you say, you know what? I want to emit twice my value, for instance, right? Or I want to emit in another type. I want to run some code here that I validate something. I need to do something much more specific. I can just write Kotlin code and say like, hey, you know what? For each of those guys, I want to repeat 5 times emitting it instead. And you can write idiomatic Kotlin code in order to manipulate your data. You don't need to memorize a trillion operators if you don't have to, because most of the time this is more than enough. And not only that, I can only say, you know what, I have a buffer of 20, but I only want to take, well, I have a buffer of 20, but I want to take only 10 of those strings. So even though the flow on the other side is sending me infinite values, I can only choose to take them if I want to. And then I can finish it. And the same goes to my application. I can just say here right now, you know what, I don't want to collect all of the things that come from the channel. I can just, say, hey, you know what, just give me 20 of those, and that's the maximum I'm gonna want to print. And yeah, I can just try it out and see if my application works. Hopefully I'm not gonna be a fool right now. So this is the one. I'm going to delete this thing because it doesn't make any sense. This is not the result I want to check. And we can run this test right now. So you see, I have my funny string printing out here 20 times, and I have this, I'm sorry, I did some type erasure here. So I just need to fix all my result. So I printed it, but then I printed the number instead of the result. That's my bad programming, I would say. But you can see that those things that are still defined as infinites, me as the server, me as the requester or the responder, I can take control at any point of the time. So if I'm saying, hey, I have like a lot of load right now and I cannot process this as far, I can just stop taking things up a little bit, and I don't need to reestablish a connection. I can just continue later when the back pressure supports it. And then when you start operating like this, the sky is really the limit. You can just take a very different approach in how you want to subscribe your applications to things and how you want to control the life cycle. Flows will only execute when collected. So if I'm not running this retrieve flow operation here, I would not really start collecting from the server, and so on and so forth. So there is a lot to unpack here. There's a lot to study. I don't think I invented any new concept to talk about here today, but what I try to do is saying, hey, with the tools that we already use more or less nowadays, and with the knowledge that we have right now, we can actually start building a lot of amazing things using the combination of Spring, RSocket, and coroutines and it's easy. If I can do it, I believe each and every one of you in the galley there can do it much easier. You saw even me fumbling here with RSC. I promise you the tool is amazing, and I did a disservice to them by getting some errors with the command line. It is how it is. One quick thing. I want to go back to the slides. I only scratched the surface about everything. So if you want to dive deeper into this crazy world of coroutines, I separated some talks by Roman Lizarov. They're amazing. And obviously, if you don't try them out in practice, you cannot get through them. So there you go. I have some links there. There's a lot of great talks about RSocket and about Spring and about the integration of both. I highly recommend the Reactive Spring book by Josh Long. I haven't been paid by him, but I do need to endorse him. Unfortunately, it's Java only. So hey, Josh, if you want to do it Kotlin version, please reach out. I would be happy to help. And yeah, big shout outs to the Kotlin user group for allowing me the opportunity to ramble on like a madman. And I will just open this up for questions. And if I didn't run off anybody there.
Don't. We have to thank you, to be honest. I really enjoyed it so far. So I think to give the rest some time to catch up and maybe ask some more questions, why don't we come back to the things Nicholas spoke about? He said that when I hear channel, I hear stateful connection, and how do you handle connection failure and connection retry? You kind of went into the detail with the idea of flows, I think, but do you have anything specific for this to add, or do you think this is the thing or the pointer you would give to?
So yeah, I try to get deep into that and say like, here's the channel, the request channel, so to speak, the model. But I try to show that it's not a hot contract. There's not like a state that you need to care about, because it's just done by publishers. So you can actually have stateful connections between the both of them if you need to. About retrying connections, I honestly haven't implemented any retry connections right now, so I couldn't give you a better answer. If I can, I would just drop you a line in the Kotlin user group, I believe. Yeah. Or if you find it out before me, I would really appreciate it. I don't have the info right now.
So for the rest who isn't on the Kotlin links Slack yet, please do it. I think there's a link in the description here. If not, I will add it. Also, we got another question from Eriko. He asks, do you have any contract test tool to use with the RSocket? So essentially, do you have anything like to...
I would like to specify what contract test tool means at this particular point in time. You mean like...
So how I understand it is essentially the contract is your interface or your API you provide. So you want to test it. So what you do is, especially if you have an API which is provided to you and you want to... as the interface between two teams, for example, so you want to make sure... Yeah, I do think so, yeah.
So I don't have any of those tools right now. I do believe that RSocket allows introspection. So if you try to get something that's not registered on that particular port, you can introspect whatever is acceptable. But right now I couldn't say to you like there's already a standard in place. I haven't seen any of those defined in one of my talks, so that may be my research speaking badly. What I could tell you is that it's probably a niche that you could absolutely exploit if you want to get into the open source game.
Love that. Yeah, so there's still a couple of days for a Hacktober left, so...
Free t-shirts, some say, right?
Yeah, I heard about that. So let's see, do we have any other questions? You already helped out Victor. Thanks for switching back. Yeah. Anything else, guys, folks?
Yeah, while people are thinking or writing. Yeah, so all of these links will be probably tomorrow on the description page, and I'm also going to post them on the VKUG page. I'm also just going to do a single Git commit on this crazy dumb repo I just built right now, so you guys can throw stones at it. It's going to be fun, and all of them are going to be in the Slack channel as well.
Perfect. So I think you already got a lot of thank yous and applause, and I can just just second that. Really, really great thing. Thanks for that. It was a pleasure having you on. I hope we can have you on again. And for the rest of you, we are always looking for speakers. So please come and get in touch with us. I hope Renato won't say that it's not worth it. And also, it's end of October, so we're getting closer and closer for December. If you are still thinking about having a great article published, we have javaadvent.com. I will put in the link down there as well. Please feel free to get in touch on the Kotlin Slack or via Googling for it on the page. And last but not least, hit this like button and the subscription button. That's it. We see each other next month. And till then, thanks, Renato.
Thank you, Oja. Thank you, everyone that was around. So yeah, smash that like button, subscribe. I've always wanted to say that, and see you around in Slack. Bye-bye.
See you then.